Hello, we'll start math by lesson 5.3, trigonometric functions of any angle. I'll start with the rules you already know, and then I'll branch out into the rules that we're going to need for this lesson. So I drew us a triangle here. So I'll label the triangle. So the x-axis, I'll name it x. I'll name the y-axis y. I'll name this r. So first of all, we have sine theta is equal to opposite over hypotenuse. We have sine of theta. This is the opposite, this is the hypotenuse, so it will be y over r. Then for the next one, we have cosine of theta is equal to adjacent over hypotenuse. So this is adjacent, this is the hypotenuse, it will be x over r. Then tangent of theta is equal to opposite over adjacent, so it would be y over x. And then we also have the reciprocal of the trigonometric function. So the reciprocal of the sine theta is equal to cosecant theta, and cosecant theta is just the reciprocal, so it's r over y. Then we have the secant, which is the reciprocal of the cosine, so it would be r over x. Then we have the cotangent, which is the reciprocal of the tangent, so it's x over y. And since we do not have an exact value for r, we can use Pythagorean theorem to get it. So we'll just do r, or we'll write the Pythagorean theorem first. So a squared plus b squared equals c squared. So it would be x squared plus y squared equal r squared. So r would equal to radical x squared plus y squared. And there we have a formula that can relate r to the legs of the right triangle. We also need to know all students take calculus. This is very important. What this means basically is that in the first quadrant, I'll write the name of the quadrants. So this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. They're usually labeled by Romanian values. So here what this means basically is all means that all are positive. By all I mean all the trigonometric functions. Here s just means that only sine and its inverses are positive, so it would be sine and cosecant, so both of these are positive. And here tan and its reciprocal cotan are positive. Here cosine and its reciprocal secant are positive, and the rest are negative. So here cosine would be negative, here cosine would be negative, here cosine would be positive, here cosine would be positive. Here tangent would be negative, here tangent would be negative, and so on. Onto the first type of question they can give you on the test. Find the reference angle for each of the following. Now the reference angle is important and you'll use it in future lessons. So there are two ways you can get the reference angle. First one is the calculator method, where you get the absolute value of shift tan, which is tan inverse of tan of the angle. Reference angle. So we'll use it on the 95 degrees. So shift tan of 95, and you take the positive value. So here it says 85, so the reference angle would be 85. So this would be the angle, this is the reference angle. And the second method, which is also important because you'll use it in other ways, is you look at the quadrant of the angle. First, we have a coordinate plane, and there's a formula for each coordinate plane to get the reference angle. So for the first quadrant, there's the degree or the angle is equal to the reference angle. For the second one, you have the reference angle is equal to the 180 minus the angle. Then for the third one, you have the reference angle equal to the angle minus 180. And for the last one, you have the reference angle equal to 360 minus the angle. Now, the reason this is the case is because a reference angle is a acute angle that's always positive. That's why we need these formulas here. So we can use it using the second method. So since the degree is in quadrant 2, because it's greater than 90 and less than 180, so it's between this range here, we'll use this formula here. So the reference angle is equal to 180 minus 95. Do this on the calculator and we should get the same answer. So 180 minus 95 equal to 85. Let's try it on the second one. So let's remove all this. Actually, I won't remove the formula. So this is our second exercise. Again, we just shift 10, but this time we have to make sure our calculator is in radian. So angle unit, then radian, then shift 10, 4 over 3 pi, and we take the positive value, but it's already positive. So it's pi over 3. So the reference angle is pi over 3. Let's solve it on the second method. Now, radian on the second method is a bit more complicated, you'd say, because this is 0 and then this is pi over 2. This is 2 over pi. This is 3 pi over 2. Then it goes back to 2 pi. You don't need to know this for the... Well, actually, you will need to know it for future lessons, but for the reference angle, you can always use the calculator. So first of all, you have to convert these to degree so you can make it easier for yourself. So pi over 2 would equal to 1.57. So I'll just replace pi over 2 by 1.57. Pi is already 3.14. And then 3 pi over 2 is 3 pi over 2. So 4.71. So it's 4.71. Then 2 pi, you just multiply 3.14 times 2. So it becomes 6.28. Then we get the value of our angle here. It's 4 over 3 pi, which is 4.18. 4.18 is between 3.14 and 4.71. So we use the formula for this quadrant here. So the formula for this quadrant here is the reference angle is equal to the angle minus 180, or in the case of radian, it's reference angle equal to the angle minus pi. So the reference angle equal to 4 over 3 pi minus pi. It should give us the same answer. Minus pi over 3. Pi over 3. Okay, let's solve a few more exercises, but this time we'll only use the first method, which is the shift 10 one. So for the first one, we have to make sure our calculator is in degree. Then shift 10, 315 We take the absolute value, so it's 45. For the second one, we need to change our calculator to radian. So change our calculator first, and shift tan negative 13 pi over 12. So it's negative pi over 12. Or actually it's not negative since we take the absolute value. Then the third one, there is no degree sign, so it's still in radian. So shift tan 3.5. Our calculator is already in radian. So it's 0.358. 0.358. For the last one, it's also in radian. So shift tan 25 pi over 4. So it's pi over 4. So pi over 4. That's how you solve it. Okay, on to the next type of exercise. They'll give you the sine 4 pi over 3, for example. Then they'll give you the quadrant. Then they'll ask you to give the value. So this can just be done on a calculator. Then you can make sure of your answer by using the all students take calculus. So in quadrant 3, sine would be negative. So our answer has to be negative. So sine 4 pi over 3 give us negative radical 3 over 2. Negative radical 3 over 2. On to the next question. They're asking us to evaluate secant 9 pi over 2. So again, we just bring our calculator. So the way you write reciprocal functions on the calculator is you just write 1 over the reciprocal of the reciprocal function. So if it's secant, you write 1 over cosine of 9 pi over 2. So then you'd write equal. It gives math error because cosine of 9 pi over 2 is equal to 0. So this is equal to 1 over 0, which is undefined. Usually when it gives you math error, then it's just undefined. Or you did something wrong. So you'll have to make sure. On to the next type of question. Uh, they're asking us to find two angles for the given condition. So the way you solve this is first you do shift of cosine so you can get the angle. So you do shift cosine negative radical 2 over 2 because you need the angle first. So this is the angle of theta here. So it's 3 over 4 pi. This means our calculator should be in radian, but it's already in radian, so I didn't switch it. So cosine of negative 1 negative radical 2 over 2 equal to 3 over 4 pi. So now we get the reference angle. We get the reference angle using the shift tan. So shift tan of 3 over 4 pi. And we take the absolute value, so it's pi over 4. So reference angle is pi over 4. So now we draw the coordinate plane. So A, S, T, C. So cosine is negative in this. No. Cosine is negative in the second quadrant and in the third quadrant. Because it's positive here and it's positive here. It's only negative in the second and third. So we use the reference angle formula for the second and third. So we split the page into two. So quadrant 2. quadrant 3. So the reference angle for quadrant 2, since it's pi, we need to use the radians version. So its reference angle is equal to pi minus the angle. Then here its reference angle equal to the angle minus pi. So the reference angle here is pi over 4 equal to pi minus theta. And here it's pi over 4 plus pi. I moved pi to the other side, equals to theta. So I'll do the one on the right first because it's just easier. Pi over 4 plus pi equal to 5 over 4 pi. 5 over 4 pi is equal to, then the second one we subtract pi and pi. Pi over 4 minus pi equal to negative theta. Then you divide by negative 1, so this becomes minus, this becomes plus, this becomes plus. So minus theta over 4, or pi over 4 plus pi, so it's 3 over 4 pi. Theta is equal to 3 over 4 pi. In this type of question, they give us a point and they ask for the 6 trigonometric functions. So we're going to use the formulas we studied at the start of the video. So we'll just write them again. Sine is equal to y over r. Sine is equal to x over r. Tangent is equal to y over x. Secant is equal to r over y. Secant is equal to r over x. Tangent equal to x over y. So let's get r. We know that r is equal to radical x squared plus y squared, which is equal to 4 plus 25, which is radical 29. Okay, let's remove it for space for the sign. Or I'll just move it. So sine is y over r. Y is, this is x, this is y. Negative 5 over radical 29. We cannot have radical in the denominator, so if we just write it on a calculator, it will fix that. Negative 5 over radical 29 is negative 5 radical 29 over 29. What it basically did is it multiplied both the numerator and the denominator by radical 29. So I'll just use the calculator to fix all the radical in denominator from now on. So negative 2 over radical 29, and the calculator negative 2 radical 29. Negative 2 radical 29 over 29. Y over x, negative 5 over negative 2, the negatives goes away, then 2.5. R over y, radical 29 over negative 5, r over x, radical 29 over negative 2. It doesn't matter where the negative is, but I'll rewrite it, I'll put it in the middle. Radical 29 over 5, negative radical 29 over 2, equal to negative 2 over negative 5, so 2 over 5.